Let's talk about one of the biggest, strangest puzzles in all of space travel, moon dust. For decades, we've known it as this relentless, destructive enemy. But what if I told you this microscopic menace is also the secret to humanity actually living on the moon, and maybe even going way beyond? Just listen to this. That's from Eugene Cernan, the commander of Apollo 17 and the last man to walk on the moon. Think about everything he faced. The vacuum of space, insane temperatures, complex machinery. And what did he call the single greatest obstacle? Dust. That right there tells you just how big of a problem we're talking about.
So, here's the central question for us today. How can the #1 enemy of lunar missions also be the single most important resource for our future there? It's a total contradiction, and figuring it out could literally define the next chapter of space exploration.
Okay, so let's get into it. Before we can really grasp the opportunity, we have to respect the threat. We need to look at what makes this dust so incredibly dangerous. First thing you have to know, this is not your average dust you find under the couch. The real name for it is lunar regolith, and it is nothing like sand on a beach here on Earth. It's this weird mix of super sharp rock fragments, minerals, and tiny little shards of glass that have been smashed to bits by billions of years of meteorite impacts. And this chart just puts it into perspective, right? Here on Earth, you've got wind and water constantly tumbling sand around, making it all round and smooth. Well, the moon doesn't have any of that, so its sand is made of these tiny, jagged, razor-sharp particles. They're incredibly abrasive, actually harder than steel. And to make it all worse, solar radiation gives it an electrostatic charge, so it clings to everything. It's like a superpowered static cling from hell. And this isn't just some theory. You can ask the Apollo astronauts. They lived this nightmare. The dust got into absolutely everything. It would jam up the joints on their suits, making it a workout just to move their arms. It scratched up their helmet visors, making it hard to even see. And when they tracked it back inside the lunar module, they started breathing it in, leading to what they called lunar hay fever. It was just a constant, grinding battle. So if we're going back to the moon with Artemis missions, and this time we're planning to stay for a while, we obviously need a plan. How in the world do you fight this microscopic enemy? Well, it turns out engineers have come up with a really clever, multi-layered defense strategy. It basically breaks down into 3 main ideas. The first is passive defense, which is kind of like putting on armor, using special coatings or shields that the dust just won't stick to. Then there's active defense, which is more like having a weapon, using some kind of force to literally blast the dust off. And then there's implicit defense, which this might be the smartest one of all. It's about designing stuff in a way that dust just isn't a problem in the first place. And this is a perfect example of that implicit idea. You see, a normal hinge has all these little gaps and joints, which are just perfect little traps for moon dust to get in and jam everything up. But a compliant mechanism is totally different. It's made from one single piece that moves by flexing. No gaps, no joints to jam. You've basically designed the dust problem right out of existence. It's brilliant. Okay, now for the active defense, and this is straight out of science fiction. It's called an electrostatic dust shield. It uses a high-voltage field to create this invisible barrier. As those charged dust particles come flying in, the system actually grabs them and then shoots them away from sensitive things like solar panels or camera lenses. It is literally a dust force field. But here's the thing, defending against the dust, that's only half the story. Because while we were figuring out how to fight it, we discovered something absolutely incredible. We figured out how to use it. And this is where our whole story pivots, from seeing this dust as a menace to seeing it as the ultimate opportunity. This is the big reveal. The problem is the solution. The very same stuff that scratches visors and jams up machinery is also the most valuable, most abundant, and most useful resource we could ever hope to find for building a permanent home on the moon. And it all kicks off with this number. Get this. Researchers have figured out that if you heat up just 1 ton of lunar regolith, about what you could haul in a small pickup truck, you can get over 50 kilograms of water out of it. We're talking more than 13 gallons. Now, that might not sound like a huge swimming pool, but when every single pound you launch from Earth costs thousands upon thousands of dollars, being able to make your own water is an absolute game changer. And the whole process is just beautifully simple. Step 1. You use focused sunlight, basically a giant magnifying glass, to cook the soil. Step 2. You capture the water vapor that bakes out. And finally, step 3,
You zap that water with electricity to split it into its two parts: oxygen you can breathe, and hydrogen, which is a key component of rocket fuel. All of a sudden, the moon dust is a gas station and an oxygen factory all rolled into one.
But it gets even better. This whole concept is called In-Situ Resource Utilization, or ISRU, which is just a fancy way of saying living off the land. We can use techniques like 3D printing with lasers to melt the moon dust and fuse it together, layer by layer, into solid objects. We're talking about building landing pads, radiation shields, habitats, even tools, all made from the dirt that's already there. That means we don't have to launch a single heavy brick from Earth.
You'd think that would be enough, right? We've got air, water, fuel, and shelter. But the lunar regolith was holding on to one more incredible secret. It turns out you can actually use it as soil to grow food. So in this amazing NASA-funded experiment, scientists took actual lunar soil, the stuff brought back by the Apollo astronauts, and they planted seeds in it. And guess what? They sprouted. They actually grew. Now, it wasn't perfect. The plants were a little stressed out compared to the ones grown in Earth soil. But the fact that they grew at all was monumental. It proved for the very first time that farming on the moon isn't just science fiction. It's actually possible.
So let's just step back and look at where this journey has taken us. We started with this microscopic terror that made life miserable for the Apollo missions. And we've ended up with the single most important building block for our future in space. Moon dust is, amazingly, both the ultimate challenge and the ultimate solution.
And that forces us to ask a whole new kind of question. The moon isn't just a rock to go visit anymore. It's a supply depot. It's a gas station, a farm, a construction yard. By learning how to first tame and then harness the very dust we were once so afraid of, we might not just be learning how to live on the moon. We might be building the key, the essential launch pad that takes humanity to Mars and eventually out into the entire solar system.